All right, guys, so we've talked a bit about slope-intercept form, or at least you've watched a quick introductory video about slope-intercept form. So many of you have seen this in the past, so we know that slope-intercept form is y equals mx plus b. But let's look at a real-life scenario when it comes to slope-intercept form and what that looks like on a graph. All right, so here I have values. I have a table of values that models my fast food chains and their different burgers. How many calories are in those burgers versus how many grams of fat are in those burgers. So let's quick look at independent versus dependent variables here. So here are my two variables, fat and calories. And to me, it makes sense to say the number of calories in a burger depends on the grams of fat. Okay? More fat means more calories. So calories is my dependent variable. I can see that modeled in my graph over here, and fat is my independent variable modeled in my graph over here as well. Again, independent is going to be my x values, dependent is going to be my y values, right? So in the graph on the upper right-hand corner over here, I've graphed all the ordered pairs for my table of values. So I've just taken each of those ordered pairs, x, comma, y, and graphed those on my graph. Now recall from the past that this is not a linear, this isn't a linear graph, this is a scatter plot. Right? Scatter. So this is a scatter plot. Right? A scatter plot is just a set of ordered pairs in points on a graph. But can I turn this into a linear model? Can I do y equals mx plus b for this? And yes, I can. Now look at this lower graph here. I've taken those ordered pairs and I've fit a line through those ordered pairs the best I possibly can. And they look vaguely linear, right? So I'm going to draw a line through those ordered pairs, and that's going to be called my line of fit. Okay? That models this relationship between calories and fat in a linear form. All right? I've tried to draw that line through as many of the points as I possibly can. I still have some that are going to be above the line and some that are going to be below the line, and that's okay. But many of the points fall very, very close to the line. All right, so here's my line of fit. Can I use that line of fit now to write an equation in slope-intercept form? Well, sure I can. So if we look at, let's see if I write some of this. All right. So here's my graph again on the left. I'm going to take 2 points that look like they're pretty clearly on the line. So I'm going to go with this one right here, and I'm going to go with this one right here, because those are right on my line. So can I match those up with my table values? It looks like this one right here is somewhere around 50 grams of fat, so x is going to be about 50, and y is going to be somewhere around 800. So it looks like this is the ordered pair. That would be that point right there. My next point is right here, so that's somewhere around 900 when it comes to fat. So you can find this on the table. And somewhere around 1,300 or so when it comes to calories. Right, so let's see, 90 for fat. It's going to be here, and right around 1,300 for calories. So those are 2 points right next to each other on my table of values. So you know how to find a slope, right? You know how to find a rate of change. I'm going to find that rate of change, or my rise over run, by doing the difference between my y values versus the difference between my x values. Right? My slope formula, slope is going to be m, is going to be 1,300 minus 810 divided by 93 minus 52. Right? I started with 1,300, so I would start with 93 in the denominator as well. Right? So I want you to go ahead and do that calculation. All right, got it? So I'm going to round this to the nearest whole number to make things easy for us. So when I calculate that, I get somewhere around right about 12. I'll say 12 over 1 because I can see my rise and my run that way. So my slope is 12 over 1. So again, remember that slope intercept form is y equals mx plus b. We just found our m, 12 over 1. You can say 12, that's fine. I'm going to go 12 over 1. That's plus b. Well, I don't have my b value. Like, there's nowhere in the graph where x is 0. Or there's nowhere in the table of values where x is 0. Right? 24, 8, I go down that column. Nothing says 0 for x. So I don't have a y-intercept in my table of values. Well, I'm going to take a shortcut this time, and I'm just going to look at my graph. I'm going to estimate my y-intercept. So it looks like my line crosses the y-axis right about here. I'm going to estimate that y-intercept to be at about 100 calories. So I'm going to replace b here with 100. So now I have a linear equation for my table of values and for my corresponding graph, y equals mx plus b. Now we're not quite finished yet because we have these two questions. Well, A, we've already done, we've written our linear equation. They give the real world meanings of the slope and y-intercept. Well, what does this slope mean? Again, slope is rise over run, or y per x, right? Well, y is calories and x is fat. So calories per fat grams. Okay, so what does this mean for 12 over 1? Well, that means that I have 12 calories per each additional 1 gram of fat. So every time I add a gram of fat, I'm going to add 12 calories. Right? There's my slope slash rate of change. There are lots of different things you can call it. So our slope means there are 12 calories per every 1 gram of fat. Okay, what is the y-intercept? What does the y-intercept mean? So recall that the y-intercept crosses the y-axis. Wherever I cross the y-axis, the value of x is going to be 0. So at 0 grams of fat, I'm going to have still 100 calories. Right, so there's my y-intercept. Right, one more question for you. How many calories would I have if I have 8 grams of fat in a burger? All right, so what were calories? Were calories x values or were calories y values? Remember that we said calories are going to depend on the amount of fat. Calories are dependent. They depend on, which means fat must be, again, independent. In other words, are x values. Right, so my 8 grams of fat is going to be my x value. So in my equation, my linear model, I'm going to replace my x with 8 grams of fat. So now I have y equals 12 times 8 plus 100. So if we think about this for a second, remember that our slope meant that for each gram of fat, there are 12 additional calories. So if I have 8 grams of fat, I'm going to multiply that every 12 calories. So if I do that calculation, I have y equals 12 times 8. Let's break this down. 10 times 8 is 80. 2 times 8 is 16. So 80 and 16 is 96. Plus 100. So it appears that if there are 8 grams of fat in my burger, then I have 196 calories. In class, you're also going to have to replace that y sometime. So if I said I have 500 calories and you need to find the grams of fat, where would you replace, or where would you substitute that 500 calories? We would substitute it instead of y. And then you'd have some balancing to do, but we're going to practice more of that in class.